My name is Bernard Smilde. I'm a visual artist. I make installations and sculptures, often reacting to my surrounding and architecture and history, for instance. People have been projecting ideas onto weather phenomena for centuries because we don't really understand nature, and I think it's maybe the one thing we cannot yet control. And there's something ungraspable about nature which I think is really interesting, like all the meanings we project onto it, and I kind of like to play with those ideas. Well, I wanted to see if we could break light at a very large scale to project a rainbow onto my surrounding. And so that's what we did. We made a very large prism, and we had to have some distance as well and a projection screen, which was the barn.
David, do you need a jacket?
Yeah.
I need to get a jacket. How are
You look
you?
good
Good
because
to
you're going
see
to
you.
be cold.
We have several labs in the Boulder area, and for us this idea of pairing an artist and a scientist was very tempting and exciting.
It was really filled with the mineral oil.
Yeah.
If it heated up, it would expand, and maybe it would break the acrylic.
Oh.
So he took mineral oil out and left some air in there, so it could, the air can be compressed, but the mineral oil, not so. My name is Stephen Tomczyk, senior scientist at the National Center for Atmospheric Research. Well, I got an email from a colleague of mine, and she was looking for someone who would assist an artist who was trying to make a large-scale prismatic type display, very large scale, and looking for someone who could help, who knew about optics and could assist the artist. A prism works by bending or refracting light. And light refracts differently at different wavelengths, different colors, as it goes through glass. And that property of the glass and the light is how a prism disperses light.
So could we aim it a bit towards the barn? Yeah, and just on the...
So what we're trying to do tonight is to create a prototype display at 130 meters instead of maybe what we ultimately want to do, which is 1 kilometer. So we're trying to make a smaller scale display of this rainbow on a barn and measure the intensity of that rainbow, and then use that measurement to then predict how this is going to work at much larger distances.
It was the first time to see if it would work. Initially, the whole thing we put together, Steve and I, and so I was quite surprised to see that it worked that well, and we could measure it as well, so we had a distance, we had the light intensity, and from there on we could take it further.
I'm gonna go measure that again.
That's pretty good.
Oh, 23.9.
Yeah!
That's way up. That's way up. A rainbow is something different, actually, the rainbow in nature. It has to do with drops of water and how light refracts and reflects through those drops of water. So we're not officially making a rainbow display. We're using a prism to disperse light the same way the raindrop is dispersing light when it makes a rainbow.
Well, as an artist, I'm really much visual based, and often I run into these kind of, with my ideas and solutions, often you run into the edge of materiality, you could say. Is something still possible? How will this work? And do I have to make concessions here? And I think scientists, in a way, they just go past that or go around that. And that's what I really like. There's also an expression in Dutch. It's called meten is weten, which means measuring is knowing. And that's exactly what we did. Like on that barn, my idea kind of worked. We projected that rainbow onto that barn. But then Steve, he got up that ladder and he started measuring the rainbow. And he is like, when we have data, we can take this even further. So I kind of like that idea of, so that science helps you in that way to, well, to work together and to get to something.